Hey guys, we're going to be talking about projectile motion here, and so I'm going to give you some basic information to get started. I'm going to do 4 videos that will talk about projectile motion. This first one is just going to talk about the 3 different types. Then the next 3 videos will go into actually practicing a problem that uses each of those 3 types of projectiles. So first of all, projectiles are just basic, you guys know. It's an object that is tossed or launched, and the important thing that we're going to be looking for is that it travels in both the x and y direction, so that we see that there's actually change in the x and change in the y. So now when I'm looking at this, this looks really similar to when we just did a position time graph of an object that would go up and then come back down as time goes by. But here we're actually talking about two-dimensional motion. So we have moved past one-dimensional kinematics into 2D motion. It's very exciting. So that's for starters here. That's just the basic idea of what a projectile is. When we think about projectiles, you're going to be approaching these just like we would I'm going to smush that over there. Just like we would a constant acceleration problem combined with a constant velocity problem. So we've got both of that happening. When we think about the motion that's happening in the x direction, that motion is constant because there's no force acting on the object in that y direction, or excuse me, in that x direction. There is, however, a force acting in the y direction. And what is that force? Gravity! Yes, gravity is the force that is acting on objects in the y direction, and that causes there to be an acceleration here. So that means we're going to be thinking about this as an acceleration problem, the vertical motion, and then the horizontal motion is going to be thought of as a constant velocity problem. So since we're doing double duty on this problem, there's actually a way that I like to organize all of my thoughts for that. I create a little table, and I deal with the x information and the y information, like that. So I have everything that has to do with the horizontal motion of my object is over here on the x side. Everything that has to do with the vertical motion of my object is on the y side. So the variables that I need on my x side are going to be, first, delta x, which just means change in position in the x direction. So just change in position in the x direction. Then I'm going to need my average velocity in the x direction, which will be constant. It will be the same the whole time because nothing is causing it to speed up or slow down in the x direction. Then finally, I'm going to need my change in time, which is something that changes independently of whatever motion is happening. It has nothing to do, it's not affected by anything else. It's an independent variable. Then on the y side, I have my change in vertical position, change in y, and then I have my acceleration is my thing that's constant over here. So acceleration, you can put in the y direction. And we don't really need to put that y there because there's no acceleration at all in the x direction, so I usually don't put that y there. And I also don't usually write y's like that. Yeah. Then we've got change in time. And then we've got, of course, our initial velocity in the y direction and our final velocity in the y direction. It is important to have these labels, initial y, final y, because we've got a velocity over here. And when you're doing all your math, you want to make sure that you are labeling which velocity are you talking about, because you're dealing with 3 velocities in one problem now. You've got to be cautious. So things to note about this, we've got position. These first pieces here are position. The second two pieces here, those are both constants. So on the x side, when we're talking about horizontal motion, that velocity is constant. On the y side, when we're talking about the vertical part of the motion, that is also constant. Constantly what value, as long as we're talking about planet Earth, our acceleration is going to be the acceleration due to gravity, negative 9.8 meters per second squared. Meters per second squared. There we go. And then the next piece, time. Now, since that's an independent variable, that's the same on both sides. So that number will be the same on either side. That's the only one that is going to be universal on both sides of this table. Regardless of whether we're talking about the horizontal or vertical motion, time is always going to be that. It's going to be constantly changing independently of whatever other motion is going on. And then we've got our initial and final velocities that are changing, and there's nothing on the other side to compare those two, because the only thing that's changing on this side is position. Here, position's changing, so is this. So that's the basic stuff about all projectiles. This right here, this is true for all projectiles, every single one. I'm going to take this information and I'm going to shrink it down, and I'm going to put it over here now. There we go. And oh, you guys didn't move. You guys go over here too. And I can't get them to shrink. Yeah, well, whatever. I'm going to move them over there. All right, so now that we've got that information out of the way, let's now talk about the three different types. So I've got my first type. I like to call this the go jump off a cliff scenario type. So if I've got a cliff and I have some object on that cliff and it's shot straight out and it has that, I don't want that to look quite so flat. It's this nice little arc going down. The important thing to know about a type 1 is that the initial velocity in the y direction is going to be 0. So this is basically like dropping an object, just straight up dropping an object, except that you're giving it some horizontal velocity out this way. So that is our type 1, the jump off a cliff scenario. The other thing that's important about this one is that the change in vertical position, vertical position is going to be some negative number because the change in position is going down. So if something's going down, that's the negative direction. So that is going to need to be a negative number there. Okay, number 2. Number 2 is the same height scenario, so kind of like you're playing catch. So imagine you've got a baseball, and that baseball is getting thrown up and then being caught, and the two people playing are the same height, so that it's being thrown and caught at the same height, which you have to be really precise to make that happen. Of course, most situations are not going to be like this, but this is a type of problem that can really help us with type 3, so it's definitely important to talk about. So the idea here is now we actually have something that's being launched at an angle, and so this is where all of our trigonometry is going to come in handy, because we're going to need to figure out what angle that's being launched at. We'll get into some more detail with how that works in our next couple videos. And then we've got, when it gets back down to here, very similarly to when we talked about how if you just toss an object straight up in the air and then you catch it at the same height that you launched it at, it's going to have that same same speed but opposite direction. That's the exact same thing that's happening here. So this angle that it will make when it's coming back down will be the same as the angle that we had over here And then this velocity in the vertical direction is going to be equal and opposite to what we have over here. So that is number 2. The other thing that's really important is that the change in vertical position here from here to here, well, if it's coming back down to the same height, that means that the change in vertical position, so delta y, is actually just 0. 0 meters, 0 inches, 0 whatever, 0. And then we get to 3. I'm going to put a unit there because it's bothering me. Then we get to 3. And I'm going to draw you 2 pictures for number 3 because we can have, I like to call this one the diving board scenario. And then this one is going to be the basketball scenario. So, like that. So in this first scenario here, we've got the idea of an object starting out higher, and then hitting something lower. So it's not a same height situation. However, there is a type 2 problem hiding right in there. And so this is very similar when we talked about the that problem where we had an object where we threw it straight down at 2 meters per second. Okay, so there was that one. And then if we had the up and down, if it goes up at 2 meters per second, by the time it gets back here, it's now going downward at 2 meters per second. And so then we can think about it as being the same kind of a thing. So this is kind of my diving board idea. And then that's also happening right here. So we've got that too. My little basketball idea. I should make that like a nice orange color. Hey, look, now it's a basketball. There it goes. Whee! 2 points. And so we've got the basketball idea is just this first one in reverse, where we're starting out lower and then it's going up higher. So the most important thing to think about here is just the fact that our change in position, it's still just going to be whatever this height is, because this up and down part, the change in position here is 0, so the total change in position is just from here to here, or here to here, vertically. Horizontally, it would be from here to all the way out here, so it's a little bit different there. And then, again here, the change in position vertically from here to this height, and horizontally from here to over here, so like that. And so in the next couple of videos, we're going to do specific examples of 1 and 2 and 3, and we'll do both this one and this one, so you can see what those look like. But for now, that's all you need to know about projectiles. Thanks for watching.